All right, so what we are going to look at for this extension lesson is rewriting expressions. So we've looked at simplifying expressions and equivalent expressions. Now we want you to be able to see if you could create your own equivalent expressions. We will give examples for these problems, but there are tons of different possible answers that you could get. So first, looking at this first expression, 4x plus 8, says we want you to write 3 expressions that are equivalent to this. So you could start as easy as something like, okay, I'm going to take 14x and 8, and I'm going to say, what if I split up the 14 to 10x plus 4x, and maybe I split up my 8 to 7 and 1. These are equivalent expressions because remember, if we were to look at our x's, if we combined 10x and 4x, that would give us 14. And if we combine 7 and 1, that gives us 8. So they are equivalent to each other. All right, let's look at another expression. Let's say we did split it up even more. Let's say we do 3x plus another x is 4 plus, let's say, just 10x there. That equals 14x. And then we leave the 8 the same. That would be an equivalent expression because again, if we look at this, 3x plus another x is 4x plus 10 more x's is 14x, and 8 is the same as 8. So those two expressions are equivalent to each other. Let's try a little bit more complicated. Let's say we use that reverse distributive property. So I can look at 14x and 8, and I look at 14, 8, and I think about what that greatest common factor is. Well, 14 and 8 both divide by 2. So let's say I pull out a 2 to do the reverse distributive. So 14x divided by 2 is 7x, and 8 divided by 2 is 4. So again, you can double check your work here and see if you did that right. This would be the equivalent expression, but let's double check. 2 times 7x is 14x plus 2 times 4 is 8. All right, let's look at some more examples. Number 2, we've got 20 plus 6x. So we're looking at the same thing here. Splitting up, doesn't matter what order I do it. Let's say I split 20 to 15 and 5. Plus, let's say I split my 6x into 3x plus 3x. Again, if I'm double checking my work, 15 and 5 give you 20, 3x and 3x gives you 6x. Let's break it down easily again here. Let's say I split my 20 into 19 and 1. So 19 plus 1, that gives us 20, plus 6x. Let's say I split that into 4x and 2x. That would be another equivalent expression. And then let's again try that backwards, that reverse distributive property. So I'm looking at 20 and 6 to find a greatest common factor, or a number I can pull out. 20 and 6 both divide by 2. So let's say I pull the 2 out. What's going to go in my parentheses? Well, 20 divided by 2 is 10. 6 divided by 2 is 3. So 6x divided by 2 is 3x. All right, number 3, now we have the distributive property here. So my first thought of reworking this, would be to distribute first. So I'm going to multiply 2 times 3x. 2 times 3 is 6. So 2 times 3x is 6x plus 2 times 5 is 10. So this expression here is equal to 6x plus 10. So actually, what I'm going to do now is I'm going to use this expression that I used in number 1 to then rewrite some more equivalent expressions. So I'm going to break down 6x. Let's say I do 5x plus x. That would give me 6x. And plus, let's say I do 8 and 2. So plus 8 plus 2. So I'm going to break it down again. Maybe I start from here and I break it down further. Let's say I do, instead of 5x, I'm going to do 4x plus x, which gives me 5x, plus another x, gives me 6x, plus, maybe I break down my 8 into 7 plus 1 plus 2. This is a really long expression, but it's still equal because 4, 5, 6 x's, 7, 8, 9, 10. All right, let's look at one more. Write 3 expressions that are equivalent to 8x plus 6y plus 20 plus 2x. So first thing I'm actually going to do here is I'm going to simplify, okay? So I'm going to simplify by combining my like terms. We've got 8x and 2x makes 10x. My y's don't have anything to combine with, so just plus 6y. Plus my 20 has no numbers to combine with, so 20. That would be an equivalent expression. It is the simplified version. Now let's say I just break this down a little bit further. So maybe I keep my 10x the same. Maybe I keep my 6y the same, but maybe I split up my 20 into 13 and 7. I can keep breaking it down that way for number 3, but let's say I actually do kind of a tricky thing here. What if I use the reverse distributive property on this first expression? So I'm looking at 10 and 6 and 20 and seeing what's a common factor of them all? 2. Well, 10x divided by 2 is 5x. Plus 6y divided by 2 is 3y, plus 20 divided by 2 is 10. So it's kind of a triple distributive property there. And that's it.